Okay? So that is for that. What about this? This means the sample size, or let me write this. That's what I need to start. The sample size is less than or equal to 5% of population size. So why do we require that? So for example, let's say population size is university, UNF students, okay? And the sample size, we want to have some kind of independent opinion so that when they make a decision of yes or no for sample proportion, we want them to have independent, opinions. So the previous student's answer does not affect your answer like that. So if that is look at 5%, it is like what? 1 in 20? So roughly speaking, it's like on campus, it's like 1 in each class. No more than 2 from each class. You see, 5%, 1 in 20. So like a 1 per class. Well, therefore, they can have some, we can expect some kind of independent, their opinions. So this is like what the binomial experiment where those each trial has to be independent. So this is the same thing. We are going to ask the same question to each student, and they have to be independent. Okay, so that's why this is 5% of the population. So each and every time, to do some constructed confidence interval, yes, we have to verify this one first. Okay? Yeah, you remember I used just a normal curve. Well, I took it for granted. But we have to show this one first, and then it is okay to use a normal distribution curve, theory-wise. Okay. So before I go further, I want to emphasize just one more thing. Yeah, those confidence levels, what does it tell you? Okay, so for example, 90% confidence level and the 95 confidence level. When you this plus or minus, okay, this one belongs to this margin of error is this. And the square root of p hat 1 minus p hat over n. This part has nothing to do with the confidence level. This confidence level comes from this number, this alpha over here. And this one has nothing to do with it, only this part. As you see, if you increase the confidence level, what does it do? The critical value goes up also. So what does the critical value do? It's going to multiply, it's going to getting larger. So if this is a confidence interval for 9, with the confidence level of confidence is 90%, and then 95% for the same matter, okay, of course for the same matter, the interval is going to be wider. Why? Because this critical value is larger, therefore it will go further over here because this number is going to be larger, and this one is going to be same. This one has nothing to do with the level of confidence, only this part. So you know what I mean? So confidence level goes up, that means the interval goes wider. Yes. Then now we are ready to handle the real problem over here. Okay, here we go. Example 9.12. Yeah, this is a kind of a very, very, very relevant survey over here. In the Parent Teen Cell Phone Survey conducted by Princeton Survey Research Associates International, 800 randomly sampled. So here, random sample of 16 to 17 years old, living in the United States. Also, the population should be huge. Okay, so how many are in here? Random sample of 800. sample size is 800. What did you ask them? Have you ever used your cell phone text while driving? Okay, so each and every of those 800 people, students, basically high school students, that have you ever used texting while driving? Okay, out of that, 272 said yes. Unfortunately, okay, indicates that they text while driving. So for texting, in other words. So we got the idea, okay, we got the idea. And so what do we need to do? Okay, obtain a 95% confidence interval, 95% confidence interval for the proportion of this sample. Okay? Confidence interval. Alright, we already know the formula. So, but before you do that, you always check the check mark for these two. Alright, so number one, number two, we never fail that part. Okay. The first one, so what is, first of all, what is p hat? Okay, over here p hat is 272 over 800. Okay, so where is my, 272 divided by 800, that is 0.34, is the sample proportion. So from here, we know that one thing for sure is 0.34 is right in the middle, and we are going to give a little buffer above that and a little buffer below that. Of course, it's going to be the same length. Okay, so how this 95 confidence level is going to affect this? Well, the formula is this: p hat plus minus, so 0.34 plus or minus. E contains what? E contains this, okay? E is again z sub alpha over 2 square root of p hat 1 minus p hat over n. So the 95% go, having this one available, that is very important thing, 1.96. We already know the meaning, okay? And then this portion, let's calculate that. So that is, p hat is 0.34. Therefore, 1 minus p hat is 1 minus 0.34, 0.66 over what is the sample size? That is 800. Okay, so once you compute this, yes, this portion alone is 0.0167, but what we want over here is this portion, yes, this margin of error turns out to be 0.033. Okay, so what does that mean? 0.34, the sample proportion is right in the middle. You are going to extend that one to the right, 0.033, and you go to the left also 0.033. So let's say you add this much and you subtract this much. Make sense? Okay. So what do we have? So this at the right end, we call this one upper bound. Upper bound has to be this one plus 0, so 3.4, 0.373. So that is the upper bound. What about, of course, the other one has to be lower bound. 0.34 minus that. Yeah, so that one has to be 0.307. Okay, so what is the summary? the summary is our confidence interval is our 95%, yeah, don't forget that, 95% confidence interval, so important, okay? Interval is from 0.307 to 0.373, and our sample proportion is right in the middle. So this is the answer, okay? But that part was just pretty mechanical, and now let's try to understand over here. This one, we built this confidence interval based on this. But what does it exactly mean over here? 95% of level of confidence. So that means there is a probability that this interval contains the proper or the real proportion of population in this interval. That probability is 95%. In other words, let me rephrase it. There is 95% of probability that this interval contains the true proportion. It doesn't mean that. And then, what do you mean by 95% of level of confidence? The level of confidence means the confidence in our method over here. So in other words, if you do, this is only one sample over here. This was conducted by this Princeton survey. Okay, let's go to Associated Press or CNN or ABC. They took a poll and they have like many, but they have to be the same sample size over here. Okay, same sample size, and they make it, and then there are. So when there are large number of samples are made, then for each sample they are going to build their confidence interval. Correct? Okay. So when many confidence intervals are made, 95% of those confidence intervals will include true proportion inside. We don't know where that is. Okay. So again, you can make many different intervals like this using different surveys, okay? Different surveys with the same sample size of 800. So there are many intervals out there, and then 95% of those intervals will contain true proportion somewhere in the interval. That's what that means. Okay, we are not talking about just one particular interval over here. So that is a big one. Okay, we are not talking about this particular interval. I know that is a disappointing thing. We just built, and what that is for? Well, it just simply we learn just what is going on here, and this is just a confidence interval. But you know, the true meaning is just 95% of all these possible intervals will have true proportion somewhere in here. By the way, I forgot to mention this one. Okay, so let's say here little n is 800 is really less than or equal to 5% of this population. What is population over here? Earlier, that is Americans who are 16 to 17 years old. There are millions of them, right? So that's not a problem, okay? So this is millions. So 5% of this millions, yeah, that's definitely greater than 800. So this is not a problem at all, okay? So 1 and 2, oh, we didn't even verify number 1 yet, okay? I'm very sorry about that, but here n is 800 and the p hat is 0.34 and the times 0.66. Yes, you multiply that and you get 179.52. So almost 180. Almost 180. So that is very definitely greater than 10. okay, or greater than or equal to 10. Okay, so once you verify that and you construct based on this formula, and this E is this. Okay, so it's not too bad. All right. The most kind of tricky part is understanding this confidence interval. I mean, the confidence level. How do you understand it is 95%? Okay. So let's see. Let's change this confidence level to 90%. How is going to change that? So I'm not going to erase this part. Okay. I'm going to compare this one to 90% of a confidence level of a confidence. So confidence interval. Confidence interval. So number one is going to be wider than or narrower than this. When you lower the level of confidence, this critical value also goes down. So this critical value goes down, so that means this is going to be a smaller number. So therefore, this buffer is going to be, what margin of error is going to be smaller. Okay? So the interval is going to be from here. Again, 0.34 is right in the middle, but when you do that, it's going to be 0.367 and 0.313. Okay, you use everything the same, just change this number 2 from 1.96 to 1.645. Therefore, you are going to have a narrower interval. Okay? Narrower interval. So, how is it? Okay, so not too bad. All right. The next one is now, what are we going to do? This constructing interval. Yeah, I did it. Okay. Oh, calculator. So I'm glad that I didn't erase this part. Okay. We used, yeah, this kind of a hybrid of, just we already picked the things from calculator, those critical numbers, critical values, and we calculated this, we constructed this. So now we are looking for a magic wand. Can you do this on our calculator? Yes, we can. So what we do here is go to STAT. Okay? Go to STAT. And go to test. Yeah, in chapter 9 and chapter 10, yes, we are going to use a lot of tests over here. So go to the last option and then go to A. You have to move a lot. 7, 8, 9. The next one is A. 9, 0 and A. That gives you one prop Z interval. Okay? One prop Z interval. So go there and then click. What's it going to ask? Only 4 things. Because look at this formula. What you need is this P hat comes from what? P hat comes from X and N. So it is going to ask you X, what is little n, and the C level, confidence level, and that's it. So X was 272, N is 800, confidence level was over here 95%, so you're going to put in 095 and then see what you get. Yes, I got instantly 0.30717 to 0.37283. So that's why over here 0.307, and this one we did kind of manually, okay? So this is what you get. Alright, so it's not too bad at all, okay? So remember, this one we use STAT button, okay? The next one is how we find the sample size. So in other words, the confidence level is given. Okay? Under that given confidence level, in order to obtain this interval, what is going to be the sample size we have to satisfy? You know what I mean? So, in this case, in this formula, yes, we want to compute what this one is. Yes, we call it E, correct? Okay, we call it E. So how do you find this N? Well, we can use just algebra, yes, but I do not want to just force you to have this algebra. So this one is given. N equals P hat times 1 minus P hat Z sub alpha over 2, I'm sorry, not sub, Z alpha over 2 over big E squared. So this is margin of error. So again, we are going to use these numbers, okay? All right. So there's officially that the sample size required to obtain this level of confidence, okay? With the given level of confidence, we want to have a confidence interval for the population proportion P with the margin of error is given by this, okay? Once you compute this, this is a very important part, round it up to the next integer. So if you have n equals 102.3, and then you go to what? Your answer is going to be 103. It doesn't matter, regardless, it's not a regular rounding, okay? Always round up to the next whole number, okay? That's what you need to do. And here is a technical issue over here, okay? Sometimes P hat is P hat. We have a little bit issue over here. What are we doing? We want to compute what the sample size is. However, if you use P hat, what is P hat? P hat is X over N. So, look, sounds like we have like a contradiction over here. We are looking for N, and when you say P hat, N is in there. Can you do that? So we have to give up. Okay, we have to give up. Then what are we going to do? So we are either, okay, for P hat, we are going to use either previous P. Okay, so for example, let's say they take a survey every year. So instead of, we are in 2020, so they can use previous year's 2019 P for in this case. Okay, if that is not available, well, why? Because this is the very first time you are doing it. Okay, when you are very first time you are doing it, and what I'm going to do here is use P equals P sub, that one is going to be 0.5. Yeah.